When more than one team shares a Kubernetes cluster, traffic management becomes the most fragile part of the platform. One team updates the routing, another team application goes down. And the scary part is, nobody intended to break anything. This is not a Kubernetes problem, this is an architecture problem. So in this video, I will build a real multi-tenant gateway API setup, 2 teams, 1 gateway, 1 cluster and 0 interference. Everything in this video is mapped to this diagram. At the very top is the internet. User access application using host names like app1 and app2. And all the traffic enters through one shared gateway. That gateway exposes 2 listeners. First is HTTP, which is running on port 80, and another is HTTPS, which is running on port 443. So the port 80 exists for one reason only, that is certificate automation. But end users never touches it. We have another listener which is running on port 443 where the real tenant traffic flows. This is where the isolation matters. So the TLS is terminated once by the platform. After that, traffic is routed internally. So this separation, like automation on HTTP and tenants on HTTPS, is what keeps team from breaking each other. We will start from the bottom of the stack and move upwards. First, we will deploy the namespaces and the application on each of the namespaces. Then we will slow down where the gateway API actually matters. Here, everything starts with the ownership boundaries. So let's start by creating tenant boundaries first. In Kubernetes, the strongest isolation primitive is a namespace. So each tenant starts with its own namespaces. So first of all, let's create as namespaces for our tenants and the gateway as well. So let me go under the directory that is multi-tenant. So in this, I have already created all the manifest files. So let me open the namespaces one. So here you can see I am creating 3 namespaces. The first one is tenant-a, second is tenant-v. So in these 2 namespaces, we are going to deploy our applications. And at last, we are creating another namespace that is gateway-system. In this namespace, I am going to deploy our shared gateway. So if you notice in the tenant-a and the tenant-b namespaces, I am using the labels as well. So this label might look simple right now, but later this single label will decide who is allowed to attach route. So if there is no labels to the namespaces, so there will be no traffic routing. So let's apply this manifest file very quickly. So let me save and exit and run kubectl apply -f namespaces.yml. So all the 3 namespaces got created. Let's verify it very quickly. So kubectl get ns. So we can see the tenant-a and the tenant-b got created. And the gateway-system namespace also got created. And we have also attached the labels to the tenant A and the tenant B namespace. So we can see that using the --show -labels option. So --show -labels along with the kubectl get ns command. So we can see these are the labels which we have attached to the namespaces. At this point, we have defined who is allowed to participate. Now let's give each tenant something to run. So we are going to deploy a same application on both the tenants. Let me open the manifest file for the same. So this is the manifest file for our tenant A application. So this is the deployment resource I'm deploying here. And this application is going to be deployed under the tenant-a namespace. And here under the specification, I have specified replicas and the selectors. So as of now, I'm going with the 1 replica of this application. So here I'm using a simple application to showcase how the multi-tenant gateway works. And below that, I have a manifest file for the service. So this service will look for a label that is app equal to app1, the same label which we have defined in our deployment definition as well. So let's deploy the application very quickly for the tenant A. So kubectl apply -f. So the deployment and the service got created. Let's verify it very quickly. So kubectl get pods -n tenant-a. We can see the pod got created. Similarly, if I run kubectl get service, so we can see the service also got created. Now I will deploy another application in tenant B namespace. So let me open the file for the same. This is the same manifest file which we saw for the tenant A application. It's similar. We just use the different labels and the different name as well. So earlier we were using app1, but for the tenant B, I am using the app2 deployment. And I have also changed the label, that is app2. Similarly, I created a service for the application 2 in the tenant B namespace. So let me apply this as well. So kubectl apply -f and the manifest file name. And we can see the deployment and the service got created. So let's verify it very quickly. Get pods, kubectl get pod -n tenant-b, and we can see the pod is running in the tenant B as well. Similarly, if I run kubectl get service, so the service also got created. At this point, both tenants are running workloads. They are isolated from each other as well, and they are also completely isolated from the internet. So now the question isn't about routing yet. The real question is, where does the traffic even enter this cluster? So before we talk about TLS, before routing, we need a gateway. And this is where most people misunderstand Gateway API. In Gateway API, the gateway is not routing logic. It is an infrastructure. Its first job is very boring. Gets a public IP from the cloud provider. So let's deploy our gateway first. So let me open a manifest file for the same. So I have already created a manifest file for the same, that is shared gateway.yml. So this is the manifest file for the gateway. Here I am specifying the name of the gateway, that is shared-gateway, and I'm going to deploy this particular gateway under the namespace, that is gateway-system, which we just created. And under the specification, I am specifying the gateway class name, that is Nginx. This is the most important section, that is the listener one. We are starting with only HTTP, not because we like insecure traffic, but because certificate need a way to prove domain ownership. So if you see, I am using the HTTP only, and below that I am allowing all the routes from all the namespaces. So this is for the temporary purpose only. So we are not opening traffic for users, we are just opening traffic for an automation. So the port 80 is open, but not for the users. It exists only so cert-manager can work properly. That's why allowed routes is open for all the namespaces right now. So let's create a namespace very quickly. So let me come out of this file and run kubectl apply -f shared-gateway.yml file. And we can see the gateway got created. Let's verify it very quickly. So kubectl get gateway -n gateway -system. So we can see the gateway got created, but right now we are not able to see any IP address because it's waiting to get an IP address from our cloud provider, that is a GCP. If I run kubectl get service -n gateway -system, we can see internally it created a service that is shared-gateway-nginx with a type called load balancer. And here we can see it didn't assign any external IP as of now. And if I run with the -w option, we can see the IP address got attached to this as well. If I run the get gateway command again, so we can see the IP address is reflecting here as well. That is the same IP address which we got from the cloud provider for the service as well. So this gateway is now alive, but it does nothing useful yet. And that's an intentional thing. Now let's add an TLS here. So gateway do not create any certificates, and they should not as well. Certificates are a security concern. So we delegate that to a cert manager. So I have already deployed a cert manager in this particular cluster. So if I run kubectl get pod -n cert-manager. So we can see the cert manager pods are already running because I have already deployed the cert manager in this particular cluster. Now we need to create a cluster issuer for this. So let me open a manifest file for the same, cluster issuer.yml. So here I am creating a cluster issuer with a name called let's encrypt -http01-gateway. So here under specification, I have specified the let's encrypt server URL, and below that I have specified the email address and the private key reference as well. Under the solvers, I am specifying the HTTP01, and below that I am specifying the gateway HTTP route. So this block is very critical. Here I am telling cert manager don't create an ingress. Use gateway API instead. So let's apply this cluster issuer file. So kubectl apply -f cluster issuer.yml. We can see the cluster issuer got created, and if I run kubectl get cluster issuer, our cluster issuer got created successfully. Now the platform is capable of issuing certificates. So the next decision is simple. Who actually owns the TLS? We could give each tenant its own certificate, but in real platform that gets expensive very fast because we are going to manage renewals, debugging failures, and coordinating expiries across teams. And that's an additional overhead. So instead of that, the platform owns the TLS and the tenant owns the routing. So let's request for a certificate as well. So let me open a file for the same, that is gateway-san-cert.yml. So this is a cert manager certificate resource file. This is where we define what certificate we want, not how it issued. So under the metadata, I am defining the name and the namespace. So I'm giving a name that is platform-cert. I'm also specifying the namespace that is a gateway-system. So this certificate lives in the gateway namespace. This is the same namespace under which we have created our gateway as well. So this certificate belongs to the platform, not to any tenant. So under the specification, we can see the secret name. So here I am specified the platform-TLS. So when this certificate is issued, the cert manager stores it in a Kubernetes secret, and that secret is what the gateway will later reference. This is the name which I defined for the Kubernetes secret. Below that, I am specifying the DNS name for both the application. And this is the most important part, as this is the SAN certificate. So one certificate but multiple host name, and these host name represent different tenant, but they all terminate TLS at the same gateway. So here we need to update the IP address of the gateway. So let me copy it very quickly. So this is the gateway IP address, and if I open this and update the IP address here, so now I have updated the IP address of the gateway in the DNS name as well. So here I am referencing to the cluster issuer which we just created. So this tells cert manager who is allowed to issue this certificate. So this is the cert cluster issuer because this is a platform level infrastructure. So the pattern is simple. The platform owns the certificate, the gateway terminates the TLS, and tenant only defines the routing rules. So let's create a certificate resource as well. Let me save and exit and kubectl apply -f gateway san-cert.yml. So the certificate got created. So kubectl get certificate -n gateway -system. We can see the certificate resource got created, but as of now it's not ready. So if I run kubectl get order -n gateway -system, so it's a valid one, and let's verify the same again. And we can see the status got changed to true because we got a certificate issued and stored under the secret called platform-TLS. And if I run kubectl get secret -n gateway -system, so we can see the platform-TLS certificate got created, that is 36 seconds ago. Now that TLS exists, we can finally expose HTTPS. But this time with the guardrails, because this is where the platform becomes safe. So let's update the gateway. So for that, gateway -HTTPS is the manifest file. So if you notice, this is the same block which we used to deploy a shared gateway only for the certificate issuing. And below that, I am specifying the another listener that is for the HTTPS, because we are going to use a TLS certificate and our traffic should be encrypted. So if you notice, I am using the protocol that is HTTPS, port that is 443, and here I am specifying the host name. Anything ends with the IP address and then nip.io. Here I need to update the IP address of the gateway which we just created. So let me get that first very quickly. So this is the IP address for the gateway, and let me open the file again. And here after the star and dot, and let me update the IP address. So this is the host name because we are going to use the same certificate for all the tenants. Below that, I am specifying the TLS and the mode is terminate. And under that, we are specifying the certificate reference. And here we are referencing to the same certificate which we just created and which is stored under the platform-TLS secret under the gateway-system namespace. So if you notice, gateway only referencing to the secret. It doesn't own the certificate. And below that is the allowed routes section. And this is the very important section because if you notice, we have created labels at the namespace level as well. So we are going to use those labels here as well. Using that only, we are going to route the traffic to the application. So under the namespaces, we are using the selector option. And under the selector, we are using the match label and tenant equal to true. So this single selector prevents accidental outages. A team cannot attach route unless platform allows it. So let me apply this very quickly. So kubectl apply -f gateway-tls.yml. So the gateway got configured successfully. Let's verify it very quickly. So kubectl get gateway -n gateway-system. So everything seems to be fine here. Let's describe this. kubectl describe gateway shared-gateway and the namespace. So here we can see the listener got accepted and the listener is also got programmed, and all the references are resolved here. And if we go a little bit up, so here we can see we have a listeners. One is for all the namespaces, which is only running for the port 80 that we are using for the HTTP and the certificate issuing. Below that, we have another listener that is only for the application. And here we are using the HTTPS and the certificate which we just created. And if you notice here, we are using the labels for the namespace level. So we have created a label at the namespace that is tenant equal to true. So this is the same label which we have used for the gate. Now the tenant can safely control the routing. So let's create the HTTP route for both the tenants. And this is the heart of the gateway API. Each tenant defines routes without touching the shared infrastructure, because till here what we have did for the gateway level, it's a platform thing. Now we are going to create the HTTP route that is only for the tenant basis. So if I open tenant A route.yml, so this is the HTTP route for the tenant A application, that is the application 1. So this is the HTTP route. This is where the routing decision lives in the gateway API. So if you notice under the metadata, I am specifying the name of the HTTP route, that is app1-route, and I'm going to create another namespace that is tenant-a, under which our applications also exist. So this particular route belongs to a tenant A only, because tenant A owns these resources, not the platform. So under the specification, we are specifying the gateway information. So if you notice, we are specifying the parent reference. This is how the tenant attaches to the platform gateway. They don't create a gateway, they just reference the one. So if you notice, I am referencing to the shared -gateway and the namespace as well, that is a gateway-system, because the gateway exists under the gateway-system. And below that, I am specifying the section name. The section name points to the HTTPS listener. So TLS is already handled. The tenant never touches the certificate. So that's why I am just only referencing to the HTTPS listener of the shared gateway. And below that, I am specifying the host name, which we are going to use for our application. So we need to update the IP address of our gateway here. So let me update this very quickly. So if I run kubectl get gateway, and this is the one, and let me update the IP address. So I've used the same hostname here because this hostname must match the certificate that platform already owns. So that's a contract, because we have used the same hostname to create a certificate or issue the certificate. So we need to use the same hostname for our application routing as well. So the certificate and the hostname can match with each other. And below that, we have a rules for the backend reference. This is where the tenant decides where traffic goes, and this route sends traffic to their own service, that is app1-service. So this is the clean separation. The platform owns the gateway, the platform owns the TLS, and tenant only owns the route and the application. So let me apply it very quickly. kubectl apply -f tenant hey route.yml. So the route got created successfully. If I run kubectl get http route -n tenant-a, we can see the route got created. And if I try to access the application, our application is working fine. So we are able to access our application of the tenant A. And if I click on the certificate information, we can see the connection is secured. And if I click here, and I can see the certificate is valid, and here we can notice that the certificate is issued by the Let's Encrypt, the one which we use for the gateway. That means our application is working fine, and the TLS is also got configured successfully. Now let's do the same thing for the another application which is running under the tenant B. So let me open the file for the tenant B route. So this is the route for the tenant B application. So here as well, I'm specifying the name and the namespace, and here the namespace is tenant-b. And here also I'm referencing to the shared gateway and the HTTPS section. And here we need to update the host name. So let me update it very quickly, because this thing must match with the certificate. So let me update this. And I've used this one. So we have updated the host name to match with the certificate, and the rules I am specifying the backend reference, which is referencing to the service of our application only. So let's apply this as well, and kubectl apply -f. So the HTTP route got created for the tenant B as well. And if I run kubectl get HTTP route, we can see the HTTP route got created successfully. If I try to access the application for the tenant B as well, we can see I'm able to access the application. And we got a response from the app2-deployment pod. And if I click for the HTTPS verification, the connection is secured and certificate is valid. And the certificate is issued by the Let's Encrypt only. So the same IP, same gateway, but the different tenants. So in this particular setup, applications are unaware of the gateway. Tenant owns the routing and the platform owns the TLS and the gateway. And that separation is the gateway API model. This is not a demo pattern. This is how the real platform are built. I have already uploaded all the manifest file in the GitHub repository, and I will add a link in the description so you can use the same to perform a demo at your end as well. If you found this helpful, hit like, share it with your friends, and subscribe for more content like this. Thanks for watching. I will see you in the next one.